Okay, so we're finishing the back side of yesterday's notes. Yesterday we were starting to work with when you're taking a fraction to a fraction power. And so here's our little reminder of what we learned yesterday. If we have b being taken to a fractional power, and remember yesterday that b was, yesterday our b was a fraction, but the day before it was not. So we learned that you can take the m over n. This was actually maybe 2 days ago then. Our first thing in lesson 6.2 is you can take that b to the m over n power and break it up to that thing that we're finding the nth root of b, so that's b to the 1 over n power, and then that is taken to the numerator, which is the m power. Well, we got to use that little property along with the one that we did yesterday when we had a fraction to a power, and we said give each the numerator and the denominator its own power, and then we're going to, and again that power was a fraction, so then we had to go from there. So here we are with 16 over 25 being taken to the 3/2 power. Okay, so if we have 16 over 25 to the 3/2 power, what would be our first move in this one, do you think?
You need to plug in 16 over 2. Or, 3 over 2 into their thing where you put it out with both.
Okay, how about we do this up here? Let's make this our first move.
Oh, yeah, I don't know what's called.
Okay, let's make that our first move. So we're going to take our 16 over 25, and that is going to be taken to the what power? 1/2 power.
That's going to be taken to
And now that whole thing, so now we got to put a different kind of grouping symbol. Now we're going to use these braces like this. It's like another set of parentheses. We're going to now take that whole thing to the what power? To the 3rd power. Okay, so now we've taken it with our first property that was up there. We've broken it up so that we say, okay, here's what we're going to bring it to. We see what root do we have to take it to, and then what power do we have to take it to. Okay, the next thing that we're going to do is we're just going to get rid of that first set of parentheses there. So we're going to say we have to take 16 to the 1/2 power and 25 to the 1/2 power. And that whole thing has to be taken to the 3rd power, because now what we applied the fraction to a power rule. Give the numerator and the denominator, each of them, their own power. Well, let's take this now and let's rewrite this as, what is 16 to the 1/2 power really mean?
the square root.
Yeah, the square root of 16. And same thing with the 25, the square root of 25. Again, because we're not using our calculator to do this. So we're making it so that we can understand how to get to that answer without the calculator. Well, what is the square root of 16? 4. So the square root of 16 is 4, and the square root of 25 is 5. So now we have 4/5 to the 3rd power.
64.
Well, what happens now? We got a fraction to a power still, so what do we have to do?
4 to the 3rd power and 5.
Yeah, we have to give each of them their own power of 3. And last but not least, we have to evaluate what is 4 to the 3rd power. It should be in your powers table if you don't know it. And 5 to the 3rd power, 125. So the answer.
Simplest form, we can get any of these in.
What, is that going to be the simplest? Yeah. Here's how you'll know if you can simplify that or not. What you might want to do is you look back and you see what was the fraction to begin with. So back here it was 16 over 25. Can 16 over 25 be simplified?
No.
Yeah. So if that can't be simplified, then most likely what you end up with over here is not going to be able to be simplified either. In other words, is there anything that goes into 64 that also goes into 125? Can you think of anything?
No.
So that can't be simplified. Okay. So I want you to try this next one on your own, following what we just did.
That's why I asked you to simplify this.
this one you're done it.
Yeah, well, I said simplifies, but I don't think it does.
Okay, is there any, can this be simplified? So you're not saying that you want to simplify necessarily, but you want to.
I just wanted to know.
Right, so can 8.343.
No, it doesn't, it's like a decimal.
Okay. And what else was in the 8 beside itself? 4 and 2, right?
Yeah.
It's 4, 2, and 343.
No.
Then it's pretty likely then that your final answer won't be simplified either. Okay, Cassie, you want to come up here and show your work?
I just can't remember the steps, but I'm starting to
Just so you know, you have to.
Oh, let's show them all.
Yeah.
Okay. Here.
Okay. Okay, like I showed the steps, but I broke it down differently than you do.
Okay, go ahead, you can do it in your own.
Okay, so I just broke it down like that instead.
I'm just gonna put this here. Okay. Oh, so you did 2 steps in one kind of there?
Yeah, I
That's
just broke it down
basically-
right away.
Okay, go ahead.
No, for sure.
Let's see if we still all get the same answer.
What do we do?
I already know.
Does everybody have an answer? Are you getting close? Check with your table partner or somebody close by you, see if you guys agree, or if you're still working, just keep working. Oh, wait a minute, this is not the one. Let's switch along the way.
When we get to the step, you had that right before you had those cells there. We take 17 plus
16. We can table up there a little bit longer so we can see it. Okay, Cassidy got 2,401 over 16. Anybody agree? That happened for you? Okay, only a couple of us?
Mm-hmm.
Are we convinced then that Cassidy's right, or do you think you are? What'd you get, Jesse?
2,401 over 16.
Oh, so you got what Cassidy did also, even though
Yeah.
you didn't raise your hand?
Yeah.
Yeah? Oh, okay. So Cassidy basically kind of skipped maybe one step, showing one step here that you probably showed on your paper, and that was the step where we do the 343 over 8, keep that like it is, take it to the 1/3 power, and then take that to the 4th power. She went straight to that, didn't she? Is that the skip? Is this a step that's on your paper that wasn't in Cassidy's step here? Okay. So then she broke it up and gave each the numerator and the denominator their own power of 1/3 and 4 at the same time also. So she kind of skipped that step too. Instead of giving the 343 the 1/3 power and the 8 the 1/3 power, and then giving, she went to that. So she really kind of skipped a couple of them before she got to here. She combined into one step. Now, if you can get away with doing that and it's working, it works for you, that's totally fine. But when we did it up above, I showed you every single step to help you be able to get to where you need to get to along the way. Let's decide if our answer seems reasonable or not. Our numerator is a whole lot bigger than our denominator. Do you feel okay about that?
Yes.
Why?
Because our numerator was bigger on our, than the denominator on our regular.
That's pretty good reasoning. The numerator was bigger than the denominator in the start, when our base to start with, so in our final answer it still is. You give me another reason why now that, 2,401 is a lot bigger than 343. Why does that seem reasonable? And 16 is bigger than 8. Why is that okay? Okay, I need you guys that are starting on the homework to be processing with us here. This is an important thing to make sure we understand this. Why is it okay that not only do we end up with a numerator bigger than a denominator as it started, because it started with a numerator bigger than a denominator, so it's a good thing it ended that way, but why is it important also that 2,401 is bigger than 343 and 16 is bigger than 8? Why is it? Oh, sorry. Why should we say that's okay? We have to be able to reason out our answers. You guys just, that's why our quizzes don't go so well. You should just do them to do it and hope for the best. So Haley, what do you think?
When I put it in my calculator, I did not get that.
What'd you get?
The decimal.
Well, you are going to get a decimal.
Oh, yeah.
So I want you to take 2,401 divided by 16 and see if you get the same decimal as you got right there. But I also want us processing why 2,401 should be bigger than 343 and 16 should be bigger than 8.
So they're taking to a square or to a power.
We're taking it to a power that's what? What power are we taking it to? 4/3. What's true about 4/3?
It's greater than 1.
It's greater than 1.
That's what I was trying to say.
Were you? I didn't hear it, I'm sorry.
Oh, maybe you thought I was thinking of like the original. Right.
Yeah, maybe. So if we're taking it to a power greater than 1, does it have to get bigger than itself?
Yes.
Yeah. What is 4/3?
1 1/3.
1 1/3. So it's really being taken to the 1 1/3 power. So it's got to get bigger than it was to start with. What happened up here? Let's look at the other one. That was taken to a power greater than 1 or not? Yeah, 3/2 is greater than 1. And did we end up with a result? What do we end up with here? 64 over 125?
Yeah.
64 is bigger than
16.
16. 125 is bigger than 25. Does that seem reasonable?
Yep.
The numerator is smaller than the denominator. Does that seem reasonable? Why?
Wait, what?
The numerator is smaller than the denominator. Does that seem reasonable?
Yeah, because it was smaller than the denominator.
Yeah. So you know what? There are some times that when you get your answer, remember I say to you, you should always be asking yourself, does this seem reasonable? But you guys aren't asking yourself that question, I don't think, often enough, are you? So I only see one person ready to admit it. Okay.